Was Einstein wrong? That question sounds outrageous, almost offensive. But if you've ever tried to really understand time dilation, you may have felt something strange. Not confusion, distrust. Because we're told one story, and then another. And when we compare them, they don't seem to agree. The discomfort. In one famous example, the twin paradox, we're told that the faster you move, the slower you age. A twin leaves Earth at high speed, comes back, and is younger than the twin who stayed home. But in another explanation, clocks placed higher on Earth, moving faster due to Earth's rotation, run faster, not slower. So which is it? Does motion slow time, or speed it up? If both are true, either physics is contradicting itself, or the explanation is the assumption we all share. Here's the key thing. Most explanations never say out loud. Every one of us grows up with the same assumption. Z-time is a single, invisible river, flowing equally for everyone, everywhere. Clocks don't create time, they reveal it. And if two clocks disagree, we assume one must be wrong. That idea worked beautifully for centuries. It feels obvious. It feels necessary. And it is exactly the assumption that has to go, where popular explanations break. Let's look at a common example. Clocks placed at different heights on a rotating Earth. The higher clock moves faster. It also experiences weaker gravity. We're told the higher clock experiences more time. But then quietly, we're still told that the experiment lasted from 1 o'clock to 1:05. 5 minutes. The same 5 minutes. So, how did one clock experience more time? Inside the same 5 minutes? Now, compare that to the twin paradox. The traveling twin moves faster, travels farther, and experiences less time. At this point, most people don't reject physics. They stop trusting the explanation. And that reaction is reasonable. The missing idea. Here is the part that changes everything. Relativity does not say that clocks run fast or slow relative to a master clock. Relativity says there is no master clock. Each clock measures its own time. Not Earth's time, not calendar time, its own time. Physicists call this proper time. You don't need the math, you just need the idea. A better way to think about time. Imagine two hikers. They start at the same place. They end at the same place. One takes a straight path, the other takes a winding trail. Same start, same end. Different journey lengths. No one argues which path is correct. They're just different. Time works the same way. The clock that experiences more time isn't the one that moves least or moves most. It's the one whose path through space-time is longer, why the paradox disappears. Now we can return to our examples. On Earth, motion slows clocks. Gravity speeds them up. The gravitational effect is stronger. So higher clocks run faster. In the twin paradox, motion dominates. There's no gravitational compensation, so the traveling twin ages less. Same rules, different paths, no contradiction. Why this isn't just philosophy? If this were just interpretation, GPS wouldn't work, satellites wouldn't stay synchronized, navigation errors would grow by kilometers every day. Engineers don't debate this. They calculate it, and it works. In closing, time doesn't behave strangely. We behave strangely when we expect it to. The moment we stop asking which clock is right and start asking what path each clock took, the confusion disappears. Einstein wasn't wrong, but many explanations are. Time is not purely a measurement, but it is not a substance either. It is a physical dimension, And clocks measure how much of that dimension a system experiences along its path. Time is a real physical dimension of the universe, but it is not something that flows or exists independently of physical systems. Clocks do not measure a universal time. They measure how much time a particular system experiences along its path through space-time. Time isn't something the universe keeps track of. It's something the universe experiences.